10-1, we learned how to graph sine. 10-1. 10-2, we learned how to graph cosine. And today is our last lesson of the unit. It's going to be taking and shifting those functions, shifting sine and cosine. So recall that shifting, the nice thing is once you know how to shift one function, you know how to shift all functions. So shifting for all functions works the same. Shifts left and right, you go opposite of the sign, and it's in parentheses. So this would be a shift of right too, correct? Everyone? And then shifts up and down, the sign stays the same, and that would be added on the outside of the function. So this one would be up 4. So let's just graph. They gave you where the parent function was, the non-shifted function. X squared's graphed right here. Let's take and graph the shifted function. So this would be right 2. So let's just graph a rough sketch of that. So I'd be taking all these points and shifting them right 2. So then the next point would be over 1 up 1. So over 1 up 1 on this side. And then look, my next whole number point. So we're shifting them right 2. So right 2. This one right 2. So it looks like my parabola was just shifted over right 2. All right, this one is a shift of up 4. No shift left or right, but there is a shift of up 4. So it's taking all your points and going up 1, 2, 3, 4. So this one would be up 1, 2, 3, 4. Let's find another whole number point and shift it up 4. 1, 2, 3, 4. Next one right here, up 1, 2, 3, 4. And there's our shift of up 4. So you know how to shift the sine and cosine then, because it works the same way. Ah! That was the scariest thing that's ever happened to me. We're on tape. Okay. All right. So shifting for sine and cosine works the same. So maybe write this down. Your packet doesn't have it, but so regular and old non-shifted sine has this form. Y is equal to a sine of b theta. That would have no shift. So now we're going to have a shift left and right. That'll be added in parentheses, just like all other functions. And then we're going to have shifts up and down. That'll be added to the outside of the function. So we still have our amplitude. For sine and cosine, our period is still 2 pi divided by b. And then b is still the number of cycles from 0 to 2 pi. And then this will be our shift left and right. We go opposite. This is also called just in a shift left and right is also known as a phase shift. So if you're ever asked what's the phase shift, it's just what's the shift left or right. And then that's our shift up and down. All right. So it's pretty simple. And the nice thing is we're going to have all examples where our b is just going to be 1 when we're shifting left and right, up and down, just because we're not going to get quite to that level of having to think so much about, okay, my period is this, and now I've got to shift those. We could do it, but we're not going to because we don't need to. But in pre-calculus, you will have a b that's different than 1. All right, so it says, given the following sine and cosine functions, name each transformation. Did you need this longer? Yeah. Okay. So let's grab this. Write this down. It is on your green paper once again, but on your green packet. But I'm gonna draw my graph from scratch. So it says graph y is equal to, and everybody maybe grab a highlighter. So graph y is equal to sine of x plus 3. So what you would do is you'd first say, okay, what's my shift? Up 3, correct? Let's all list out everything we need to know to graph sine. We need to know our amplitude, which my amplitude is 1. My period for sine is 2 pi divided by b. Notice b is in front of x, right? B theta. So 2 pi divided by 1 is 2 pi. So now what you're going to do is you're going to draw in your xy axis here, your original xy. So everybody drawing this in. Here's my original x and y axis here. Now, what we're doing is we're shifting. We're going to start with, we're shifting up 3 units. So that's my new x-axis. So up 1, 2, 3. That is my new x-axis. So what you're going to do is draw in a new x-axis. And I like to draw my new x-axis as dotted. So we're taking the original sine function and we're going to shift it up 3. Other teachers are making their students graph the original function and the shift up. But if you can see it without, I don't care. Everybody understand? Let's just graph the shifted function for all I care, because that's all you're going to really see on a graph if it was a multiple choice test. So now from there, our amplitude's 1. So don't we need to go up 1 additional point, everybody? So that would be at 4. And then down 1 would put me at 2. So won't my amplitude bounce between those values? So I like to, from here, take a highlighter and kind of highlight so I know how it's easier to graph it when I know exactly how high up and down to go. So grab your highlighter and go like this. Okay, I'm going to highlight this line here because that's how high up my amplitude goes and how high down my amplitude goes. It just helps me then graph it much quicker and more accurate. Because now I can see more exactly where I'm looking at. And now we'll go ahead, and since that was our only shift, we'll label the x-axis. So we're still starting at 0 since there was no shift left or right. So we'll go over 1, 2, 3, 4 tick marks, and that puts me at 2 pi, right? Let's graph 2 cycles. Over 1, 2, 3, 4 puts me at 4 pi, filling in the x-axis. I like to fill it in on the original x-axis always. So then this will be pi, right? So then this will be pi halves, 5 pi halves, 7 pi halves. And now when there's nothing to shift up or down, it's really easy. So now we can literally just graph it in. So we're still starting at the origin here. We're still starting at this 0. So now we're up here graphing though, because it's shifted. So then for sine, it starts at the 0, everybody, right? So 0, then the next point will be at the max, correct? For sine. Because remember, sine looks like this. 0 max, 0 min, 0. Okay, here we go. So the next point will be at the 0. You got to kind of picture it in your head. The next point, the min. The next point, the 0. Let's draw that in. There's my first S. Now let's draw on our second cycle. Now make sure to line it up. 2 pi, we ended in the right spot. Okay, next point. So 0, then max, then 0, then min, then 0. And I'm drawing in my second S, and we're done. Just gonna shift it up. Shifts up or down are pretty straightforward. Okay, let's do this one. Graph cosine of x minus 1. So we would say my amplitude is 1. My period is 2 pi divided by b, which b is 1. So my period is 2 pi. And then we're shifting this down 1. So you would do that same thing. Here we go. So now we're shifting down 1. So there's my new x-axis, negative 1. So I like to draw in, once again, my dotted line. Then my amplitude is 1. So I'm going to highlight so I know where it's bouncing between. Amplitude is 1. So we'll be at 0. And then down here at negative 2. And then there was no shift left or right, so my x-axis is still the same. My period's 2 pi, so I'll go over 1, 2, 3, 4 tick marks, that's 2 pi. 1, 2, 3, 4 tick marks, 4 pi. We would fill in the rest of the x-axis, which I'm not going to take the time to do, because you can fill that in. Now cosine starts at the max 0, min 0, max. So we'd go right here. Here is my new origin right here. So then it would start at the max, correct? Max. Then the next point, the 0. The next point, the min. The next point, the 0. The next point, the max. So I've drawn in one cycle for cosine there, and then obviously it's going to bounce and come back down. So then max, next point 0, next point min, next point 0, next point max of the amplitude. Pretty easy, right? Yes. Because it's not, we shifted down to -1, right? So from there, amplitude means how high up or down from the midline. Isn't my midline now down at -1? So that means we still have an amplitude of 1, right, everybody? Good question. Yeah, I want you to draw in 2 cycles, yes. Yeah. Okay, here we go. So this is where it gets a little bit trickier. So shifting left and right. So I'm going to give you some hints to make it a little bit easier. So first of all, you'd say my amplitude in this one is 1. My period is still what? Bx. So it's still 1. So my period is still 2 pi divided by 1, which is 2 pi. But now we're shifting all of our points right pi halves. So here we go. Everyone ready? So let's draw in, I like to call it like my rough sketch here. Well, I'm going to call this my good sketch, my official sketch. So there's my XY axis. We're shifting, no shift up or down, but we are going right pi. So we'll come back to that in a second. Okay, so let's draw in what I call like my dummy. When I shift left and right, I have a dummy x-axis that helps me see where my new points are going to be. So let's say there wasn't a shift of right pi halves. Wouldn't we be going over 1, 2, 3, 4, and that would put me at 2 pi? Because our period's 2 pi, right? 1, 2, 3, 4 puts me at 4 pi. Now I need to do at least, so let's fill in the rest of the x-axis here. So this would be pi, this would be 3 pi, this would be pi halves, 3 pi halves, 5 pi halves, and 7 pi halves. I'm going to fill in some negatives as well because I'm shifting it left and right. So I'm going to now go in this direction as well. So won't this be negative pi halves, everybody? And then maybe negative pi. That's maybe good enough. Okay, so looking at my original x-axis. But now we're taking all those points and we're shifting them to right pi halves units. So what I like to do is literally take and add, and so we also have 0. Don't forget about that. We're going to add pi halves to all of these. Because we're shifting them right pi halves. And that will give me my new points. So right here we're adding pi halves, and right here we're adding pi halves. So this point will now become -1 plus 1/2 is -1 plus a half is negative pi halves, correct? So write out your new, these are going to be your new points we're going to use, so negative pi halves. Then look, negative pi halves plus pi halves, won't that be 0? So that will be shifted to 0. 0 plus pi halves will be pi halves. This will become 1 pi halves plus 1 pi halves will become pi, and then 1 pi halves. So does everybody see how this is working? 3 pi halves, and so on. So 3 pi halves plus 1 pi halves is 4 pi halves, which is 2 pi. So we can keep going, but that's good enough for a minute. Let's go back up and label our x-axis. So we're going to be looking at, so we'll be going, we have a point at 0, point at pi halves, one at negative pi halves, notice. And the next one would be at pi. The next one at 3 pi halves. The next one at 2 pi, and so on. 2 plus a half is, and you can do it in your calculator, 2 plus a half, I think it's 5 pi halves. So this will be 5 pi halves. And then 6 pi halves will be 3 pi, and so on. That's some good amount of points here. Now I can keep going. Let's just keep going, finish it off. So 7, 8, won't that be 4 pi? Everybody? Yeah, we need to do 2 cycles, so we need to do. But we have to remember that we shifted. So our new y-axis is actually going to be over here at pi halves. So we got to go one more. So 4 plus a half will put me at where? 4 plus a half. You guys get what I'm doing? Shifting 4 pi, 9 pi halves. Okay, now we can stop. So next thing is, we shifted right pi halves. So what you're going to do is put your new y-axis. This is actually your new starting point. You got to start here. Is anybody lost? So shift left and right. Make sure you put in where you're starting now. That's my new y-axis. So now let's highlight our amplitude to make our life easier again. So our amplitude is 1. So 1 and -1 is where we're going to be bouncing. So make your highlighter. Here we go. So let's highlight how high up or down. Oops. Not very straight. Okay, so we're going to be bouncing between the highlighter here. So now we'll go ahead and draw it in. Now you got to start here at pi halves. So cosine, wasn't this a cosine one? Mm-hmm. So now what we'll do is we will start, cosine starts at the max. Here we go. So starting here, you got to start at the new starting point. We'll start at the max. So max, 0, min, 0, max. And there's one cycle. Then, yeah. Did I miss something? 7 plus 1 would be 8 pi halves. What did I miss? I should have a tick mark in there. That's bad. So we really should have this. 7 pi halves. 4 pi. Okay, that would have been bad. 9 pi halves. Okay. Now, good fix. Now let's continue. Very good fix. So now we'll draw in our next one. So max, 0, min, 0, max. You're right. I would have got right there and been like, what the heck did I do? Okay, let's finish drawing it in at least to the regular y-axis. So won't my next point be at 0, guys, if it follows the same pattern? Periodic functions. So then right here it's going to be at the min. So now we can draw in. So basically I do want to see it shifted with the new y-axis, but I want it to also be drawn clear to through the original y-axis. So now we can see what this graph would actually look like. So there's just a lot more to think about when you start shifting left and right. But luckily I'm not going to give you any where you also have these change. Like the period is always going to be 2 pi for us. Because otherwise it gets really messy, which you will see in pre-calculus. It's just a ton to think about. But luckily it won't be so much to think about because you already know how to do this. You know what I mean? So I'll just be adding on one thing. Okay, do you want to do one more like that? Here we go. So quickly here. So we're graphing this one. We would say our amplitude is 1. My period is 2 pi. And we're shifting left pi fourths. So what we're going to do is draw in my what I'm going to use, and then I like to have my dummy XY axis because it's easier for me to see. So if it was not shifted, we'd be over 1, 2, 3, 4. We'd be at 2 pi. Over 1, 2, 3, 4 puts me at 4 pi, and filling in the rest. Let's do some in the negative direction. So this is negative pi halves and negative pi. Okay, so now we're shifting them left pi fourths. So you're literally subtracting pi fourths from each of these. So let's just write down the new point. 1 minus a fourth, everyone, quickly. And if you need to use your calculator, negative a half minus a fourth, because we're shifting left pi fourths. So let's figure out these new points. Minus pi fourths. Okay, so what was this one? Positive? Negative 1 minus 1/4. Negative 3 pi fourths. Cool? Negative 1/2 minus 1/4, everyone. Just do it in your calculator, everyone, quickly. Don't wait just for those two to do it. Everyone do it, because we would go much quicker if we all were helping out. All right, starting back over. That's okay. Guys, negative 1 minus 1/4. Thanks. Okay, and then what does this one become? 1/2 minus 1/4. Yeah. Yep, it is 1 pi fourths. So 3/2 minus, everybody, 3/2 minus a fourth. And then 2 minus a fourth. And then 5/2 minus a fourth. Three pi minus a fourth. And 7 5/2 minus a fourth. And then, okay, cool. So we're golden with those. Okay, there's our new point. So that's what we're going to label our new x-axis. So here we go. So let's first draw in, okay, so our new y-axis will be at, if we shifted, it was 0, right? Oh, I forgot to write 0. We got to have that in there. Isn't 0 minus a fourth negative pi fourths? Okay, so let's draw that in here. Our new y-axis will be at negative pi fourths. And the point that came after that was negative 3 pi fourths. That's enough in the negative direction, so that's why I'm going to just not graph those. Now in the positive direction, we obviously at 0, right? And no, we weren't at 0. We were not at 0, my fault. But wasn't my next point at pi fourths? Sorry, I start to think too hard sometimes about these. So the next one would be at pi fourths, right? 0, and then that minus, yeah. And then my next one will be at 3 pi fourths, 5 pi fourths. Okay, perfect. We've done the hardest part. Now we can use our highlighter. Our amplitude was 1. So let's highlight up 1. That's how high up we're going to go. And then down 1. And now you're going to start at your new y-axis right here then. So this is where we're starting. It's sine. So sine is 0 max, 0 min, 0. Here we go. 0. Next point, max, which would be this point, right? No, because we don't have a 0. That's why it gets confusing here. But do you see how if we shifted, none of them became 0. So 0, then max, 0, min, 0. 0, max, 0, min, 0. Perfect. We ended up at the right spot. So I know we've done this correct. So let's continue the pattern into the negative a little bit. Won't this be down here? Okay. So now let's draw it in. So the shifting left and right is a little bit more complicated, obviously. Just the hardest part is getting the x-axis, yes. That's why we shouldn't be using our worksheet, because it's really hard to put it. So we're going to literally just, I'm going to have you on the test, do it on scratch paper and everything, and not make you put it back on. So you have to look in, like, let's say it was like a multiple choice test. If their x-axis was different, you kind of have to think of like where, like if they were at pi halves, that would be like somewhere pi halves. So you have to figure out where it is and look at your graph. It's kind of hard. It's hard to match up graphs. Okay, let's do one example where we have both, a shift left and right and a shift up and down, and then, or maybe I'll have you practice some and then we'll come back to where we have both. Or do you want to just do this last example and then let me let you go? It's your guys' what? One more example and let you go where there's two shifts left and right and up and down, and then we'll be good. Okay, this is my last example here. So we would say this is a shift, an amplitude of 1. My period is 2 pi divided by b. B is 1. So my period is 2 pi. We're shifting left pi and down 2. I don't know. Maybe it would be easier to like actually graph the original and then shift all your points. But I just hate having to graph two things. Anyone else? Okay. Here we go. So let's draw this in. So what you're going to do is you're going to draw in your new XY axis. So we're shifted left pi. So let's draw that in. Back pi. So minus pi. And that's my new y-axis. And then we're shifting down 2. So down 1, 2. So there's my new x-axis. All right, now my amplitude's 1, so let's highlight where we're talking here. So from the new midline, we're going to go up 1 unit. Since this was down 2, wouldn't that put me at -1 here? There's my amplitude, and then my amplitude would be like this as well. So you would want to label that. For example, this is -1, -2, -3. Everyone good? No one confused? You have to call this your new origin. So just keep in mind new origin. This is pi right there. Okay. Now filling in the x-axis is the hardest part once again. So I like to have my dummy x-axis. If it was not shifted, we would be at 0, 1, 2, 3, 4, 2 pi, 1, 2, 3, 4, 4 pi. And then let's do one in the negative, a couple in the negative. So pi, pi half, same thing. 3 pi half, same thing, right? Everybody, what? I can't remember. I'll have to look. So here we go. Okay, so we're adding and then negative pi. So we're adding pi to all of those since, no, we're subtracting pi. It was actually shifted up left pi. So we're subtracting pi, subtracting pi, subtracting pi, subtracting pi, subtracting pi, subtracting pi. Okay, so let's hurry. Everybody, some of you take some of these points, some of you take the middle, some of you figure out the other. So that when I say, what's this? You can do it. Well, this one's easy. -1 minus 1. Very good. -1/2 minus 1. -3/2, -3 pi halves, right? 0 minus pi is negative pi, which is that point, right? Negative pi, everybody. You see it? And then we have 1/2 minus, so we've done all of these, crossing them out. 1/2 minus 1 is negative pi half. Very good. All right. And then that becomes 0, doesn't it? 0. And then 3/2 minus 1. And then 2 pi minus 1 pi is pi. So these are my new points in this exact order, just keeping in mind. 5/2 minus 1. Yep. And then 3 minus 1 is 2 pi. We're almost there. 7/2 minus 1. And then 4 is 3 pi. Okay, so let's list this out. So notice we've already listed out negative pi. The next point is going to be negative pi half. So I'm going to have to squeeze that in there. Negative pi half. So tick mark, tick mark. So now that was over 1. And my next one will be at 0. Okay, good. Then pi half. So let's draw it to scale as much as possible. Pi, 3 pi halves. And then we could do some in the negative direction, so this would be, but we don't need to if it's past, like this is good enough here. So here we go. So starting here, this is where it's getting messy. So everybody look, this is my new origin. Is it cosine? It's sine. So 0 max, 0 min, 0 is the pattern. So right here is my 0. The next point will be at the max. The next point, the 0. The next point, the min. The next point, the 0. There's 1. 0, max, 0, min, and we ended up in the right spot with drawing it. Oops, missed that point completely. And we're good. Good enough. Okay, you guys good? Okay. Sweet. So what you're going to do is finish. Holy cow. Okay. Finish the worksheet. What I want you to do is go to number 5. We're going to keep it pretty basic. Go to number 5 and fix it to be this. Well, what there is there's a 2 or something in front. Just scribble out the 2. We're not going to get that complicated in secondary 3. And then on number 10, there's like a something in front here. Scribble that out. We're just going to keep all of our periods 2 pi. I've never done that in secondary through regular. You will do it in pre-calculus, but then you'll have learned all this other stuff. So all of our b values should be 1. Okay, grab a scratch piece of paper. It really is easier to graph these on your own paper.